We have completed week one, which was talking about the syllabus. We had a quiz. We had a tailgate. You should have received your ebook. All loose ends should be tied up, and if not, let me know and see if I can help. I'm sure you by now know who Daryl Woodrum is. He is our director for the associate degree program. So if I can't help you, I'm sure Daryl can. What you're looking at right now is the review in soils that's in section 1, as I'm saying right here. Now, let me clarify this NCCER one more time. Soils Module Section 2. The National Center for Construction Education and Research has a curriculum that we use in our certificate programs, and I like the soils module to get us off on the right foot in the associate degree program course, Soils, Basic Soil Science, PS 101, that we're in right now. But I want you to understand clearly that this information, this review, as I'm looking at right now, comes from the NCCER module Soils, and that's their number for that module. And it's based on section 1. Now, we start at section 1 because we're just now beginning to get into the subject matter of soils. The first week was entirely admin stuff. It did have a quiz on the syllabus. It did have a tailgate in it. And it did have some videos you could watch to help you with Canvas's Big Blue Button. But now we're moving into the meat and potatoes. I just happened to start this little video, and it was on this page, but I want to go back. Well, no sense in doing that now. There is a section in here. No, changed my mind. Go back. Review, go to course modules. There's my little upper left arrow. So here's where we are, the characteristics of soils. Right, we're here now. This is behind us. Please make sure you have finished this pre-test, because what's going to happen, regardless of the score you make, as you may remember or recall, this is to help us, the staff, me, the instructor, to see what you do know now. If it's nothing about soil other than it's dirt, that's okay. That's a good start, you know. Everything is built on dirt. Everything. Okay, so be sure that's done. Week 2 is about the types and some characteristics of soil. The video that we're talking will go right here. And I wonder if it has, let's see, let's look at this. I think here's where the objectives are. For the week, identify some types of soils, identify and explain the soil properties. When I say properties, I'm talking about, engineering properties, such as, are they a plastic soil like silly putty? Are they cohesive, as silly putty? Are they clay silts? Are they granular like gravel? That kind of stuff. And I want you to understand soil density. I want you to thoroughly understand that. It's determined, how it's determined, and its relationship to compaction and moisture. Moisture acts as a lubricant when compacting things like gravel or any other kind of soil. You can overdo it with moisture. You can underdo it with the amount of moisture, but there is a test that we do called a Proctor test to determine for any specific soil the optimum moisture content that we need for solid, good compaction. Permeability is the ability of water to move through a soil. Obviously, gravel is very permeable. In other words, water can move through it at a pretty good clip. Clay, on the other hand, is very cohesive. Cohesive means tight, means together. Like our group right now, we don't know each other. We're not very cohesive, but we'll get that way as time goes by. So, a cohesive soil doesn't provide good drainage, especially under a slab, because it retains moisture. And then as it dries, it begins to break apart. And that's when you get the cracks in your brick veneer on the outside wall of your new home, and the crack in the slab of your new home. That comes from the expansion and the cohesiveness of the soil that you're on. So know that. Uh, uh, Compactability, strength, and other factors affect the results of your soil. You're trying to provide a foundation for a building. Identify different soil classification system. We will mention too the AASHTO, the American Association of Highway and Transportation Officials, and the ASTM something or another, which is the Unified Soil Classification. The AASHTO is way more stringent because it's for roads and highways and things. Unified Soil is a lesser, what can I use? Less tolerance. In other words, it's not as stringent as the AASHTO, but it's good for houses and other things of that nature. And we'll take a quick look, or you'll take a quick look in section 1 about the sand cone test, penetration, penetrometer, a few tests that you can use in the field regarding soils. Now, let me get back here. I wanted to see if I could do this in 15 minutes. I don't know if I can. I want us to get a good start at any rate. So let's get back to the modules. So here we are again in module 2. There's a conversion chart in here from metric to standard, or whatever we do here in the United States. I don't think you're going to need it. There may be, as we move deeper into the other textbook, basic textbook, which is an ebook, you'll see some things presented in metric, but we can do it any way we want to. This is the thing you need to do here, because you'll have a quiz and you'll have an assignment. Those two things are graded. You'll also have a tailgate, and this one's wide open. It has several prompts in it, and I'll get to that in a minute. I want to go through this right quick. As you see, this is a review of this. It goes over what's in here without detail. It's going to talk about what you need to know when you read this module, and that's your assignment. Your basic assignment is to read this module. This part of your assignment is to know what to look for in this module. So then, you do anything you want to, but I want you to be able to pass this assignment that talks about soil properties and characteristics. There'll be some questions that probably are not multiple choice. There'll be a quiz, which I forget, it's probably not very long, but I want you to be able to pass it. Again, I want to go back and cover this with you. Okay, so this is the review of that NCCER Soils module, the section 1 of it. And it says that this is pages 1 through 13. I think there's 30-something pages in the whole module. The following notes are not an assignment. They're meant to guide. Well, actually, they are, me telling you to do it through section 1, and hopefully emphasize pertinent information as we continue to study of soils. The following notes are not I already said that. Be sure to study the trade terms listed beginning at the beginning of the module. And I'm not saying memorize them, but if you'll note as we go down through here, there's some things that are emboldened, and that means they're some of the things I want you to know about. So I want you to understand the relationship between density, compaction, and how that relates to the soil strengths. Density, let's see, is measured in weight per unit volume, specifically pounds per cubic foot. Pounds is the weight, this is the volume. How many pounds can you get in a cubic foot? The more pounds you can get in that same cubic foot, the more dense and the better the soil is to support, the better the strength of the soil is. And the reason this relationship is density is compaction creates density by adding some moisture to it, and for lubrication. So that's that relationship. Ask yourself how the terms relate to density. The module begins talking about density. I'm not sure about that, but it does talk about density and how it relates to the strength of soil, how well the soil holds up under stress, for instance, and the weight of the building. How does it hold up under the weight of the building? Density is achieved through compaction, and compaction is defined as the deliberate application of pressure or vibration to eliminate air voids. Soil consists of three components: water, solids, and air. The voids are the air voids between the soil particles. Think of a jar of big marbles versus a jar of little marbles. How much weight can you get in that jar with little marbles versus big marbles? You can get more weight in that same size jar with little marbles because you don't have as many air voids as you do with big marbles. So that's the idea of density, to achieve density through compaction, get rid of the air void. And I got a therefore. Soil strength is measured by density. The stability of any building relies on the stability of the soil on which it is built. And it's determined through a system based on particle size and their distribution, where the particles are. Are they mixed? Are they indifferent? Well, it's best that you have some small ones, some bigger ones, all different size particles. That's the better soils. Types of soils. For construction purposes, soil is classified in two types: granular or fine grain. Granular soils are like sand and gravel. Fine grain soils are like clay and silts. They're tight, they're cohesive. The granulars are more permeable, and they provide a better foundation. They can be compacted. Here are the two types of classification systems: the American Association of Highway and Transportation Officials, better known as AASHTO, and the Unified Soil Classified System, only known as. It is an ANSI, has an American National Standards Institute number, and it's also known as that. I forgot it. But it's in your terms. Later, we'll continue to take a deeper dive into AASHTO and the Unified later on. For now, I want you to look them over, see if you can see the similarities. They're both classified with the amount of granular soil compared to the amount of fine soils, such as clay. That is the determinant. The general classification of both of these are granular and fines. So, in section 120 of the module, soil properties will be discussed, and these are general and are described by features such as the grain size, the grain shape, the surface texture of the grain, And it will also refer you to Table 3, which will offer some visual and manual means of identifying soils. We're not going to do much of that, but take a peek. But before you leave, actually, when we get into grain size, which is 1.2.1, I want you to look at figure 8 on page 8. It's going to show you how we classified these soils using sieves. Sieves are little round pans, and the bottom is like a screen, window screen, and the holes in the screen are different sizes, and certain size particles can pass through there. And between the sizes and the weight of the remaining soil that didn't pass, that's how we're able to begin our classification. So Table 4, which is similar to what we'll be using to determine the suitability of soil units based on their retention or passage through these sizes. So we get on down into 1.2.5 into engineering properties. And as you read into here, pay attention to the Atterberg limits. Up here, all we've talked about before is grain sizes. Now we're going to be talking about Atterberg limits, which refer to the liquid limit of a soil, the plastic limit of a soil, and their derivative, which we'll get into later. I don't want to talk about that right now. Will be used during the course. Figure 10 on page 9 illustrates as moisture is added to a solid or a semi-solid soil, the soil moves to a plastic and into a liquid state. It goes from solid to milkshake texture, mud, and then to liquid. The limits as the results of adding moisture at which these transitions, those limits, take place, plastic and liquid limit, is based on the percent of moisture at each limit. That tells us the suitability or classification of the soil. Table 5, notice coefficient of permeability. I don't think it explains that very well, but it is the ability of water down here, the ability of moisture to allow water to flow through it. In other words, there will be a situation in your assessment, I think, in your assignment, in week 2, that will relate to permeability. So be sure and look at that table 5 and be sure you understand what permeability is. Here, I'm not sure, it does talk about the coefficient of permeability, which is noted as K, is the velocity in meters or centimeters or feet per second of water, how fast it flows through a soil. Fine-grained soils such as clays might have values of around 10, so it's slow, meters per second or lower. Or a sand and gravel formation could be 10 to 4 meters. 4 meters per second or higher. Coarse-grained soils and sand and gravel are more permeable than fine grains as silt and clay. Returning to the table, let's say we have water flowing through our soil sample at 0.3 to 0.4 feet per minute. What type of soil do we have? I'm not going to tell you, it's in the table. Probably medium to coarse sand. And would that work well on the water side of a pond dam? No, because it's too permeable. These are the types of calculations and determinations we will be conducting throughout the course. The rest of section 1, though it's important, it's pretty simple, straightforward. Finish reading because it's going to talk about maybe some of the different tests. Yes, the sand cone and the Proctor test and some of the classes of soils. Again, this is not, I say it's not an assignment, but in reality it is, because I'm telling you to do it. I'm telling you to read this for your benefit. It'll help you pass that test. Okay, I don't think I did this in 15 minutes. Maybe I did, maybe I didn't. But at least now we have a little intro video. And that's that for now.